Welcome to qnawire.
The objective is to determine the optimal value of M for coding an audio signal with specific parameters and transmitting it within a given bandwidth. 1. The audio signal has a bandwidth of 10 kHz, which means that the highest frequency component in the signal is 10 kHz. According to Nyquist's criterion, the sampling rate should be at least twice the highest frequency component, which means that the sampling rate should be at least 20 kHz. In this case, the sampling rate is 24 kHz, which satisfies Nyquist's criterion. 2. The signal is quantized into 256 levels, which means that each sample can be represented by an 8-bit binary number. 3. The signal is coded by means of M-RE-PAM pulses. PAM stands for pulse amplitude modulation, which means that the amplitude of the pulse represents the value of the sample. M-RE-PAM means that there are m possible amplitudes for each pulse. The value of m determines the number of bits that are transmitted per pulse. For example, if m equals 2, then each pulse can have one of two amplitudes, which corresponds to 1 bit of information. If m equal to 4, then each pulse can have one of 4 amplitudes, which corresponds to 2 bits of information. 4. The ρ-off factor r equal to 0.2 means that the bandwidth of the transmitted signal is not exactly 30 kHz, but is slightly larger than 30 kHz. The exact bandwidth can be calculated using the formula B equal to 1 plus R asterisk R, where B is the bandwidth, R is the symbol rate, which is equal to the sampling rate divided by the number of samples per symbol, and R is the ρ-off factor. In this case, the symbol rate is R equal to 24 kHz/256/2 equal to 187.5 symbols/S. Substituting into the formula, we get B equal to 1 plus 0.2 asterisk 187.5 equal to 225 kHz, so the available bandwidth is 225 kHz, which is larger than the required bandwidth of 30 kHz. 5. The best value of M can be determined by considering the trade-off between the number of bits per symbol and the signal minus-to-minus noise ratio SNR. A high value of M means that more bits are transmitted per symbol, which increases the data rate. However, a high value of M also means that the amplitude levels are closer together, which makes the signal more susceptible to noise. The SNR can be calculated using the formula SNR equal to M2